Hi everyone, Krishna this side. In this video, I'll be covering this aggressive cows problem from the Gigs for Gigs, and it basically falls under the binary search. And I just want to cover this problem. So yes, let us go through the problem statement first, and then we will discuss about the logics, and then I'll write down the solution as well. So you are given an array with unique elements of stalls, which denote the position of the stall. You are also given an integer k, which denotes the number of aggressive cows. Your task is to assign stalls to k cows such that minimum distance between any two of them is the maximum possible. Okay, yeah. So let us look into the example and we will get better understanding about this one. So we have these stalls which are denoting their locations, and k is how many cows that we have, the aggressive cows. So we need to put these cows in a such a way that whatever the minimum distance that we get between any two cows should be maximum. Okay, so let us talk about this one. We have 1, 2, 4, 8, 9, these different locations, right? So the first cow, if we place at first location, second cow we try to place at second location. So what is the distance between 1 and 2? It is basically 1, right? So yes, the two cows we were able to place. Now third cow, if we place at fourth location, it is like the distance between 2 and 4 is basically 2. So what is the minimum between these two? It is actually 1, correct? Yeah, that is correct. Now what we do is, if at second possibility, if we try to put the first cow at first location, second cow at fourth location, fourth stall. So what is the distance between 4 and 1? It is basically 3, correct? And the third cow, if we try to place it at this 8, so what is the distance between 4 and 8? It is basically 4. Okay, so these different distances we got by placing the cows at different locations or the stalls. So what is the minimum between them? 3, correct? Now if we try to put the first cow here, second cow here, third cow here, so what is the distances between any two of them? So between 1 and 4 it is 3, and between 4 and 9 it is 5. What is the minimum distance between them? 3. So yes, this is another possibility. Next one is like we put it the first cow at here, second cow at here. So what is the distance between them? It is actually 7, and third cow we can put it right over here. So between this 8 and 9 the distance is actually 1. The minimum distance between here is 1. So yes, there are multiple possibilities where we can keep cows at different locations, and we try to figure out the minimum distance. Okay, so out of all this, the minimum distance that we got, which is the maximum, is actually 3. So 3 is something what we have to return. We have to write. Okay, so that is something what we have to return from these functions. So yes, the idea is pretty much clear now. So how to bind this with the binary search, right? So yes, we will look that. So yes, if we look into this input stall, basically they are not sorted, and binary search basically works when the data is actually in a sorted order, right? So what we do is basically first thing is we will sort this array. Okay, so let us look into this image first. So this is the stall that we have, and yes, once we sort this array, it looks like 1, 2, 5, 7, 10. Okay, so what is the lowest answer that we can get when we try to keep the cows at different locations? Okay, so the lowest possible answer is going to be between 1 and 2, the distance is 1, right? If the stalls are like side by side, the answer could be 1. So that is the lowest answer that we can get it, right? So the low should pointing to 1 basically, and the high should point to whatever the stall that is at the farthest location and the nearest location. Between them, whatever the distance that we get, that should be the high. So let us think, like if we have two cows, the first cow we place at this location, the second cow we place at this location. What is the distance between them? It is 9, right? So yes, 9 could be the answer if we have only two cows. So between this, the possible answers is something what we can get. So this is the range that we have now, 1 to 9, and in between this 1 to 9 there could be one possible answer, which is actually, I mean, we can get multiple answers, but whatever the maximum answer that we can get, where we can keep cows at different locations and it is satisfying the conditions as well, that is going to be the answer, right? So yes, we got the range now, so we can figure out the mid. So mid is something what we got 5, so we try with the 5. So we try to keep the cows at different locations. Okay, the moment we get this 5, so whatever the distance between two cows, if it is greater than or equals to 5, we can keep our second cow at that location. Okay, once we keep the cow at that location, let us see in this same example. If I put my first cow here at first location, can I keep my second cow at this location? Because the distance between 1 and 2 is basically 1. and we are trying to see if 5 could be the answer. Okay, this is like we are trying to see if 5 is the minimum distance that we can achieve. So here the minimum distance between 1 and 2 is basically 1, so we cannot keep our second cow at this location. So let us look into this particular here. So between 1 and 2 the distance is 1, so here it is not possible. Between 1 and 4 the distance is 4. Is it going to be a possible answer? No, right? So basically we are trying to see if 5 is something what we can achieve. Okay, so this is not the answer that we are looking out, right? So when we try to keep our second curve at this location, so the minimum the distance that we are getting is 6. Okay, so between 7 and 7 minus 1, if we do, the distance is 6. Basically 6 is greater than 5, so we are trying to see if even if it is equals to 5, that is going to be satisfying our condition, because 5 is something what the answer that we are trying to look. Okay, so 6 is satisfying, so second curve we can keep it at this location. And now we can try to figure out if we can keep our third curve. If it is possible, then the answer is possible, right? This could be a possible answer. Okay, so now we try to see between 7 and 10, the distance is basically 3. Is it going to be answer that we are trying to look for? Because we are trying to see if 5 is something what we can achieve. So this 3 is something what we cannot achieve. So now the loop we are coming out of from this one. Okay, we cannot try to put our first cow at second location, because it is best to keep our first cow at first location, because the distance between 1 and 5 is basically always the largest than distance between 2 and 5. So yes, of course, every single time we will try to keep our first cow at the 0th location only. Okay, because from there only we will be going to get the best answer possibly. Okay, so yes, the first cow always we will place at first location. That is going to happen for all the cases. Okay, so now we were able to keep only 2 cows when we try to look into these arrays, and we have 3 cows to place between different locations. So this is not the answer that we are looking for. Okay, so if 5 is not possibly the answer, is it going to be the 6 or 7 or 8 or 9? Because this is the range that we have, right? 1 to 9. If 5 is not satisfying, is it going to satisfy 6, 7, 8, 9? No, right? Of course, we are not going to look for those whatever the remaining values that we have in the array after 5. So what we do is basically the high that we were pointing at 9, we will try to shift it from 5 minus 1, because 5 is not satisfying. So we will look between this range is something what we now reduced. So our new range is like 1 to 4. Between this, if we can get the answer, we can update the answers, and we keep on trying to see if we can get the highest possible answer. Okay, so 5 is not satisfying, so high is now pointing to mid minus 1. Okay, so our new this binary search values are like low equals to 1, high equals to 4, the mid is basically 2 now. Okay, now we try to figure out if 2 is the answer that we can get. Okay, so first curve definitely we will place at 0th location. We will try to see if this distance between the two stalls is basically greater than or equals to 2. If it is greater than or equals to 2, then we can keep our second curve at that location. Okay, so here it is 1, we cannot keep. Here it is 4, so 4 is actually greater than or equals to 2, right? So yes, we can keep our second curve at this location at 5th stall. Okay, now the distance between 5 and 7 is basically 2. So it is greater than or equals to the minimum distance that we are trying to figure out. So we can keep our third cow at this location, and the moment we can able to keep our all cows with all different locations. So yes, we are actually uh, able to place our cows at different locations, right? So yes, it is satisfying. So mid is basically the answer that we are looking for. So answer is something what we will update it with 2. Now 2 is satisfying, but there are few chances, right? Like 3 and 4 are also there in our array. Those could be answers. The moment if any value is satisfying, lower than that values, definitely they all will satisfy at any point in time. Okay, so yes, if I try to see like one is going to be satisfying, right? So yes, we will try to see higher possible answers, because the minimum distance should be maximum, right? So 2 is satisfying, we'll try to see if 3 or 4 is possible, right? Because that is the range that we have now. We are left out with that range only. One will definitely satisfy if 2 is satisfying, right? So what we do is our new low basically points to mid plus 1. So mid is basically 2, so low is basically 3 now. So new range is like low actually 3, high actually 4, the mid is actually 3. Okay, for 3 also, if we try to figure out this same thing, it is going to satisfy the answer. So let us see here, between 1 and 2 it is 1, between 1 and 4 4, so 4 is basically greater than or equals to 3. So yes, 3 this is satisfying, so second cow we can keep it at this location. When we try to keep the third cow between 5 and 7, it is the distance is 2. which is basically not satisfying because we are trying to see if 3 is the possible answer. So 2 is something what we got between these two. So yes, it is not possible. But now for 10, if we try to keep, what is the distance between 5 and 10? It is 5. 5 is greater than or equals to 3. So yes, it is satisfying. So we will update our answer, and again we will shift our low to mid plus 1. Okay, now low is basically 4, high is basically 4, mid is basically 4. So yes, we will try to see if 4 is going to be the answer or not. So again, if we look into the same here, between 1 and 2 the distance is 1, between 1 and 4 it is 4, so 4 is greater than or equals to 4. Yes, it is satisfying. Second cow we can keep it at this location. Now between 5 and 7 it is 2, it is not possible, right? So now between 5 and 10 the distance is basically 5, so we, yes, we can keep our third cow right at this location, right? And 4 is satisfying again. Now 3 cows we were able to place it at different locations, and minimum distance that we can achieve is like 4. Yes, it is satisfying. So what we can do is, this is the answer that we can have. Okay, now we update the answer and let us shift the low to mid plus 1, that is going to be 5. The moment the low is actually greater than high, that means we are done. We tried out between different ranges and we come out of loop. And yes, the whatever the answers value that we got, that is going to the best possible answer, and that is something what we will return. Okay, now let us write down the code, and with the code also I'll try to explain the logic again. And yes, if you guys able to get it, best, that is best for all of us, right? So let us sort the array first, because they haven't sorted it, and we can see here, right? So binary search won't work it like that. So let us get low. A low is basically pointing to 1, because that is the lowest answer that we can get. Int high equals uh, stalls of let us get the length n equals stalls dot length, and n minus 1 minus stalls of 0. Okay, whatever the best possible distance between them, that is the answer we can have, while low less than or equals to high. Let us get the mid. Int mid equals low plus high minus low divided by 2. Now we got the mid. We will check if is possible, if this mid is possible, whatever, if this mid is possible or not. That is something what we are trying to figure out. Pass the stalls k n. If it is possible, then what we do is basically low we will update to mid plus 1, and answer is something what we will shift. Answer is actually basically points to mid. Okay, let us create the answer as well. Int answer equals 0. Answer we have updated it. The else case, if not possible, then whatever the values for that we can get, those will also not possible, so we reduce the range. So high basically points to mid minus 1, and at the end return the answer. The moment we get the answer, we will keep on updating it. Okay, now let us create this is possible function. Static boolean is possible. The first is this min distance that we have, if it is satisfying. The second is stalls. Third is the cows, and last is the length of the array. The first cow is basically we will point at 0 location, so the cows is currently pointing at the first cow. We actually place it at the first location, right? So the cows count is basically 1. The second thing is like since we are keeping at so first location, so we will get this where we are currently at, false at 0, because there we keep our first cow, right? Now let us loop through this for entire I equals 1, I less than stalls. Okay, we got the length I plus plus. We check that if whatever the stalls of I minus start, if it is greater than or equals to mean distance. If that is the case, then we are simply keeping our cow at that location. We update the cow, and the start is now pointing to stalls of I. Okay, that is simple, right? So what we are trying to do is if we able to place the cow, whatever distance between 5 and 4 is 5 and 1 is basically 4, right? Now we able to keep the cow. So the start basically points to here, and we keep on checking the further distances. That is something what we are trying to do. So the moment we update this cows and stalls, we check that if cows basically equals k. If we get that, so we return true from here. We were able to place all the cows, or else in at the end we return false if we not able to keep all the cows in different locations. So we return false. Okay, that's all I think. So let us run this code. Okay, there are errors. Okay, line number 9 stalls. Okay, cow. Okay, here also I should update it. What is that? Okay, that's it. Hmm. Okay, again there is another error. Line number 33. Here it should be 1. I hope that's all. I guess expecting any more errors. Okay, expected answer. Let us submit this code as well. Now, if we talk about the time complexity, here we are sorting the array, so it is going to be n log n. Okay, it is satisfying. N log n is the time complexity here for sorting the data. And to do this binary search operation, the highest basically, let us suppose if distance whatever that we get, if it is let us suppose m, so log m is something what we will do binary search, because that is the range that we have, right? 1 to m, so log m. And again in this is possible, here we are running this for loop each time for m time, so n times, so it is like n into log m. Okay, so n into log m plus n log n, that is the time complexity that we will be having for this one. Okay, I hope you guys get the idea about this problem, binary search problem that we just tried to solve. Okay, so if yes, hit the like button, and thank you for watching this video. Bye bye.